let's go back to November 2023.
Yeah.
Sonnet 3.5 was out for a few months. We had GPT-4. Coden was just starting to finally work. We also had the event of November 17th, the OpenAI and kind of Sam Altman ousting. And it was just a very ripe time. We found an email that you had sent a kind of alum group about, I don't know if it'll come up or not, about the early kind of vote. There it goes. I think this is like the earliest innings or kernel of the thoughts of cognition. Maybe talk about where your head was at the time and how you were thinking about it.
Cool. Awesome. Well, first of all, thank you for having me. I'm super excited to be here. It's actually kind of, I didn't realize I set this at 11:59 exactly. So when we got started, we were a bunch of friends who had all known each other for a long time. Many of us had known each other for years and years and years. And we were exploring different ideas in AI, as everyone was. And we were really excited about code, partially because we were coding nerds ourselves, partially because we just felt that there were a lot of clear breakthroughs to happen. End of 2023 is right around. Oh, thank you. End of 2023 is right around when RL was really starting to work in the labs, where a lot of things started to become possible, and we had this view basically that there was a real window where full multi-step processes, iterative processes were going to really start to work. And obviously now we call those agents, but back then there wasn't really such a name for it and a category for it. And we were talking about this. I remember this. We were in New York, actually. We had lunch and we were talking about, there's probably an opportunity to start something here. I think there's going to be a lot of interesting products to build and new surfaces and everything. And we had lunch. And then as soon as we got out of that lunch, it was that Friday, November 17th, we heard the news that Sam Altman got fired from OpenAI. And so naturally we said, okay, well, if there was ever a time to go and start a company, it's probably right now. And I remember spending a ton of time on this email and saying, okay, we have to get now is the time to get the pieces together and build the critical mass and make this happen. It's kind of funny reading the email because obviously, Sam got unfired like 2 days later, but I think by then we were already down the path and we were already doing it. We had the initial team, and I think with this kind of initial group, like everyone was like, hey, let's go build something, let's go do something together. And so we got a hacker house together. It was in Burlingame, California. We were there for like a week and a half. We were iterating on a ton of ideas. At first, it was very theoretical, researchy stuff, like improving problem solving in code. And then we did another hacker house, and eventually it became Devin.
Awesome. And not only was it 11:59, it was on a Friday night as well. So that, says something about how you spend your Fridays. But
yes, indeed.
But let's move a bit to Cognition. So I think on the website it's called an applied AI lab. And obviously research and engineering are both very important and critical to what you're doing. Maybe talk a bit about how you think about organizational structure, how you view research and eng. Maybe talk about, if you're open to it, some of the research areas you're interested in. How do you think of research areas you focus on versus where the labs would focus on? And like, where do you bet on model progress versus what do you do in-house?
Yeah, sure. So we think of ourselves as an applied AI lab, specifically distinguished from a foundation lab. And the way that I would kind of describe it as a high level is I think both companies do research, both companies build products, right? I think there's a question of which one is in service of the other, basically. And I think from a foundation lab, obviously the goal is to just kind of like advance basic research and to kind of, build the state of knowledge. And from there, the products that come out from that are the ones that then get built. For us, it's the reverse, which is as an applied AI lab, we are most focused on figuring out how to build something that people will use and to deliver a product of value to our customers. And all of the research that we do comes from there. And so naturally, as you can imagine, there are certain trade-offs where, we don't really spend time trying to figure out a new attention mechanism or something like that. We spend a lot more time trying to figure out much more kind of like practical, like hairier type problems, like things like, what is the right way to process and understand a large code base? What is the set of information that you can pull? How can you, build a fast, responsive agent that can go and, explore a code base and figure out the right things quickly? How can you teach Devin how to use Datadog really well if it needs to be able to do that to go and debug, things like that. And so that's a lot of what we spend our time on. And in practice, I think how that splits between the work that we do and the work that the foundation labs do, which, obviously we partner closely with all the labs as well. A lot of the work that we do, I would basically describe in the category of solving a lot of these very particular practical problems of what being a software engineer entails. And so like one way that I like to say it is like there are a lot of labs, foundation labs that focus on code. We focus on software engineering, which is a little bit different. And so something like, hey, like this, like my Kubernetes is down. Like, let me go through the logs and figure out what happened and, restart the service and then see if that worked. There's obviously a lot of what on, but is not necessarily just, writing and analyzing like logical code problems in a vacuum.
As a small follow-up to maybe go a little bit deeper. So RL has been popular for, some time and really popular again in the past couple months. We also had the Andre Kaparthi talk where it was something along the lines of like RL is like horrible, but it's the best thing we have. Maybe touch a little bit on that comment, touch on how you guys use RL internally and just anything you're willing to share.
Yeah, I think horrible, but the best thing that we have is actually a pretty good description. I mean, I think the state of things today is basically, you can kind of think of the platonic ideal of RL as the ability to solve any benchmark. It's basically like if you have a really great eval set of here are all the use cases that I have in mind, and here's the set of tools that you're allowed to use, and here's how we evaluate whether you succeeded or failed at the task. You can just give that to your model like over and over and over, and it's way more finicky and annoying than this in practice. But in theory, you can basically just give that to your model, and then you wake up the next morning and you have a model that goes and aces that. And at first, people kind of thought like, okay, well, if you can solve any benchmark, then we're done, right? I mean, obviously, every announcement that people put out is something about like, oh, we solved this benchmark, we solved that benchmark, and now we can get to the point where someday we'll just solve every benchmark. I think in practice, there's actually a lot to do from that because specifically, RL doesn't really generalize. And there are lots of reasons for why that is, but I think to some degree it makes sense. Like we were talking about this like Kubernetes example, you can learn a lot obviously as a broad software engineer or by doing math and physics problems or things like that. But there's some amount of going and debugging this Kubernetes deploy that like you have to just have done before, in order to have to be able to really, really do. And so I think the natural question then for basically all of us in AI is, so you can train a model that aces any benchmark. What is the benchmark that you want to ace, right? And so in practice, what a lot of this work looks like and what it has, started to converge towards is basically figuring out the exact environments, the exact tasks, the evals, how you determine success or failure, and building around that and then creating models that can go and solve that, right? And code is, I think, one of the first to really get there with RL because you have this very clean feedback loop where instead of having a human have to judge it or whatever, you can just go and run the code.
Awesome, thank you. And then so next will be on kind of competitive programming. So for anyone who does not know, Scott is one of the world's best competitive programmers. I think the world's best competitive programmer is a guy named Gennady who actually works at Cognition. You did a retweet from Mark Chen, who's the chief researcher at OpenAI. And it was about OpenAI did a full score in the ICPC. They, I think, scored 6 in the IOI. They got a gold IMO this year. You made some comment about how difficult that was. Yeah. Why was that surprising? What comes next? And what is like a non-obvious consequence that follows from all of this? Yeah.
I mean, I think it's a good example of the power of RL, which is getting a gold at the IMO is pretty hard. Like it's just, I think like maybe the simple way to put it is like most of the things that we do and work on in our day-to-day lives are not harder than getting a gold at the IMO. And obviously it doesn't mean, this is, I think, where it gets to this kind of like RL eval world, which is it obviously does not mean that this model that can get a gold at the IMO itself will just go and do everyone's jobs for them or something like that. But I think what it does mean is it's a very clear proof of concept that we can teach the model some incredibly hard things that basically with the right feedback loops and the right curriculums and the right setup, you can train models that can do some incredibly difficult stuff. And I think the natural conclusion of that, I think, is not that is not that everything's over or that all these things are gone, but it just means that like as limited as RL is, it's very clear that in the right circumstances you can teach it to very powerful and very useful stuff.
Awesome. You've made the comment publicly a few times that you think we have AGI already. There's no shortage of people who talk about AGI, ASI. Yeah. Maybe touch on why you think that is. What is that moment we're going to look back on? And then as a nuance, maybe it's the same. Do you think of what code AGI means, and is that a thing in your mind? And what is that if it is?
Yeah, I mean, it's a bit. So it's a bit of a facetious comment from me. I mean, I think like the way that I would say it is like I think it's very hard to define what AGI is. You know, people sometimes say this thing of like, okay, AGI is when we've like automated 80% of human labor. And then my first thought, whenever someone says it, is like, doesn't that mean like the tractor was AGI? Because like, you know, at some point, more than 80% of all we were doing was just farming, right? Like there are obviously a lot of versions of this, and naturally, what happens is humans do the things that the automation cannot do, right? And so like, it's kind of like if you use the post definition, like humans should never be doing things that are automated. If you use the pre definition, we've done this 80% many times, and so it's like very hard to say. And I do think like. Someone told me this joke earlier, which I liked, which is, you know, in 2017, if you asked if we had AGI, the answer is no. In 2025, if you asked if we have AGI, the answer is, well, you have to define AGI, and it depends on, which I think is kind of true. Like, I mean, we passed the Turing test, we've solved some incredibly difficult problems, we've like made novel breakthroughs. You know, we all have this thing on our phones that can just talk and think, you know, almost like a human. And so maybe one way to say it is, I think there's actually not going to be a super smooth cutoff of what it turns over, and I think we as humans are, you know, we're proud of ourselves, and we want to be able to say like we'll always look for the one thing of but the AI can't do that, so that's not AGI, right? But I think in practice, probably the bigger practical shift is when we get to the point where AI just changes all of our day-to-day lives significantly and makes people much more productive, or, you know, gives people a much wider option set of what they can do. And that, I would argue, is happening already in front of us. So
today, the best competitive programmer, I believe, is still Gennady and not an AI. Do you think that changes in the next 6 or 12 months?
Oh, interesting. So it's interesting. He actually feels very strongly that it will not beat him in the next 12 months, which is good. He should be bullish. I'm like 75% that it does beat him, but I can see worlds where it does not. The thing that's kind of interesting, by the way, too, is like a lot of it actually does come down to the same data and like benchmark question, which is, I mean, obviously, you can ask the same question of Go or of poker or of any of these things. It's quite odd, you know. I mean, if you think about like the scales of intelligence, right? There's like an ant, and then there's like, you know, all of the various, and then there's like a monkey, and then there's like, you know, humans, and then there's like, you know, the lowest to the highest possible human is like a tiny sliver of the range, and then there's like super intelligence and whatever, right? It's kind of odd as an idea that the best AI is getting like number 6 in the world, but yet there are 5 people out there that are still better, you know? And I think the reason for that is not because of a fundamental intelligence gap in terms of what the AIs can learn. It's because at some point when you get to the hardest possible questions, there's just much less data available on like, yeah, like there's like a totally new problem type that has basically never been asked before or something like that, right? I think basically as humans, if we had created tons of harder questions, like it would already be better at these things. But we're seeing in practice too, where the bottleneck is more like the data and the evals that we create.
So let's talk about maybe something you've learned or experienced since Cognition. So say 2 years ago, auto completion or tab complete and Copilot were all the rage. I think a lesson maybe we've learned or taken away is that the model capabilities are somewhat coupled to like the end form factor. Tab complete's very good in the IDE. The CLI has unlocked new things. We now have, agented use cases and async agents. Maybe talk a bit about the evolution, what you've learned, and then maybe more interestingly, I think humans think very linearly. The progress is like very non-linear. So what is a use case today that doesn't work very well for agents, but you think will be amazingly well in a year from now?
Oh, that's cool. Yeah. No, it's crazy to think about. I mean, like, it's still the case. Like 18 months ago, the only thing that actually worked in code was single line tab completion, right? And like it is, I mean, we've gone through like 10 generations of products since then. First there was like multi-line tab, and there was chat with Codebase, and then we all went all the way obviously through these like basic multi-turn agents that were synchronous, asynchronous things, automated testing, wikis, and all these other things, CLI, etc. I think it is kind of crazy. And to your point, I think like, it's funny, right? Which is like I'm sure people have seen this chart of kind of like the doubling times of agents in terms of like how long can an agent work without being interrupted or without needing guidance from a human. And that number is, in code, it's doubled every 2 to 3 months. And the thing, to your point, is it's actually not just this like smooth curve where like every doubling you like are thinking about different problems. Like if you're now going from, seconds to minutes, like seconds is kind of tab complete, right? Because it's just like it saves you the next 2 seconds. And if you go from seconds to minutes, then you have to actually be able to do things like navigating between different files and like, finding the right things and doing some basic stuff like running the CI or something, right? And if you're going from minutes to hours, then you have to be able to like plan out an actual task and so on, right? And so the problem form factors change as well. I think the big things that I would bet on, or the big things that we at Cognition are really betting on, maybe the one way I'd describe it is everything in the software lifecycle, not just the part of writing the code itself. I mean, if you think about it as an engineer, like probably spend less than, you spend a minority of your time literally writing the code, at the keyboard, right? And you spend a lot more time doing lots of other things, right? Like reading and understanding the code base, like planning out a task, like reviewing, going and testing code yourself. And I think we're seeing a lot of progress in a lot of these things. So like to make some concrete predictions, like I think it is automated testing is still quite early today, but I think like very capable, computer use agents that can go and actually write some front end change and then go and test the whole thing and click around and send you the video screen cap of like, here's what I tried and here's what it looks like now. I think we'll be very capable within the next 12 months. I think there will be much, much better utilities for you as the human to be able to work with AI to really just understand some really unfamiliar code base. And like, if you were to just like sit down and say, okay, I want to re-architect the whole billing system in the code base, right now, there's not really something that helps you until you get to the point of, okay, I know exactly what code I want to go and write, and now I use the AI to help me write that code. I think there will be much better tools for you to be able to actually just say, okay, I want to think about re-architecting the billing system, and then it just feeds you all this info of like, here's how things are currently, here's the trade-offs that were made, here's what you could do differently, do you want to do this, do you want to do that? So I think that'll get a lot better. And then similarly, I think like AI PR review will get much, much better, like automated bug catching and so on.
Probably one or two more questions left, but in terms of let's talk about product. What is a controversial product or design decision or trade-off you made with building Devin and Windsurf?
Sure. Yeah. Well, there are a lot of them. I mean, I think the first one was just Devin itself. At the time, it wasn't even that long ago, but it was like, yeah, like everyone thought we were crazy, right? Of like trying to go and build like this full autonomous engineer that could go and do all these things, and like iterate multi-turn. I think recently there's been a lot of these different, Wiki, for example, is something that was like, I think no one was really thinking about such things at the time as well. And I think in practice for us, the way that we think about it is, I think the motivating question for us always is just, what is the future of software engineering and what do we think it is? And to your point, it's very dependent on what particular capabilities come online and what exactly happens. But we always, I think, and especially at a time where things are so hot and everything is going crazy at once, I think it's really important to just stay laser focused on, okay, well, how do we think code will actually be written in 5 years or in 10 years, and just making sure we get closer to that.
Awesome. So for the closing question, also for people who don't know, Cognition is your second company. You were the co-founder of Lunch Club. What have you learned from co-founder Lunch Club to starting Cognition to now? What's been a lesson or something interesting?
Yeah, I mean, I think one piece of advice that comes to mind for like all the founders in the room which is something that I feel like I've understood and learned more over the last while, is just, I think the most important part of founding a company is basically like being honest with yourself. Like I think as people get started, there's an understanding of like, okay, I've always got to be optimistic. Like I've always got to believe, I need to be the person and the force that really pushes things forward. And I think in practice, of course, there's some long-term sense in which that's true. You need to believe that it's possible, but that doesn't mean that you should just go and blindly pursue things when you already have, evidence of what's working and what's not working. And it's like internally at Cognition, like one of the things that we say all the time is like, oh man, Devin was so bad at this thing, or like, wow, I can't believe this thing. And I think it's like, it's really important for us to be able to just call out all of the things that we can be doing better and think about, all of these things like, is this the right strategy? Should we be doing this? Should we be doing that? And I think especially in a world where things change so much, what you're betting on is really, is not that you had the exact right view of the world at the start, but more just that over all of your iterations and all of your work that you will get there. And I think that's an important thing.
Awesome. Well, thank you.
Yeah. Thanks so much for having me.